So let's do one where we're doing the midpoint rule now. Let's do the same problem, but instead of using the trapezoid rule, so we're going to do the midpoint rule. Use the midpoint rule with n equals 5 to approximate the integral from 1 to 2, 1 over x dx. Okay. All right, so the midpoint rule, I'm going to call it M5. It was the sum. I have delta x in each term, and then I need to figure out what the midpoint is, right? So maybe first what we should do is think about our subintervals. So we started at 1, right? 1. And our next one was at 1.2, 1.4, 1.6, and so forth. Okay? So in these intervals, so let's look at the first one, 1 to 1.2. What's the midpoint of that? 1.1, right? So the midpoint here is 1.1. Between 1.2 and 1.4, what's the midpoint? 1.3. Okay, 1.5, and so forth. Okay, so now we can go back and plug in what the values of our midpoints actually are. Okay, so let me scoot down a little bit. So it's going to be delta x, and then it'll be f of 1.1 plus f 1.3, f of 1.5 plus f of 1.7 plus f of 1.9. Okay? So now I just need to plug in my information. We already calculated delta x in the last problem. What was delta x? It was, that was after we already divided, right, by 2. It was 0.2. That was kind of a trick question I just asked you. And then you're just going to plug each one of these numbers into the function 1 over x. Okay? So 1 over 1.1 plus 1 over 1.3. And then use a trusty calculator to approximate this decimal. So I'll tell you 0.691908. So I just have two different approximations, right? I used the trapezoidal rule in the first one. So when we did that, we got 0.6956. And then when I use the midpoint, I add 0.691908. They're pretty close to each other, right? They're off by what? 0.004 from each other. Okay, so they're pretty close to each other. Any questions about the way we calculated any of that?
How do you get like the 1.1 and the 1. I get like that's the midpoint, but I don't like.
How did I know?
Yeah, how did you know?
So we were looking at. Let me come down here actually and show you. So we were looking at the interval. Oh, not that color, black. We were looking at the interval from 1 to 2. And in the last problem, we calculated delta x, right? It was 0.2. So I know my intervals. I go up, I add each number, I add to it 0.2, 1.6, and 1.8, okay? Those should all be equally spaced. It's just not drawn very well, but they are, okay? And then, so if you look, I have 5 subintervals. I have from 1 to 1.2, 1.2 to 1.4, 1.4 to 1.6. So I have 5 different little chunks here, okay? There's one here, there's one here, 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 and here. And in each one of those chunks, you're going to take the midpoint of that. So the midpoint of 1 to 1.2, that's how we get this 1.1. The midpoint of 1.2 to 1.4, 1.3.
So you're doing the midpoint for each of the different intervals.
Yes, each of your subintervals. Yep, 1.5, 1.7, and 1.9. Yep. Any other questions? Yep.
So you don't, in the original function, where you have 1 over x.
Uh-huh.
You ran 1 over x, you don't, do the
We aren't actually integrating because we want to do problems that we're just approximating them. So in theory, we're looking at ones that you can't actually integrate. But we have to start with an easy example so you actually know how to integrate that, but yeah. Other questions? Yeah.
For the trapezoidal rule, why did you have a 2 in some of the numerators, whereas the first one?
Yeah, it's because, so let me go up to the formulas and try and show you why that happens. I said for the trapezoidal rule, whoop, don't move that. What we're doing is we're averaging our equations from the left and the right endpoint. And so what's going to happen is you're going to have a sum, and some of the terms are going to match up. So that's why sometimes you're getting a 2, but the 2 endpoints of the sums, like they start and end at different places. And so that's why the beginning and the end doesn't have a 2 in the coefficient. Okay. Other questions?